Good morning. In this class, we are going to start about the frequency division multiple access. As you know that frequency division multiple access, multiple users can able to share the available single frequency spectrum in different way like FDMA, TDD, FDMA, FDD like that. So one phone circuit per channel. Ideal time causes wasting of resources. You know that simultaneous and continuous transmitting by sharing the available single spectrum by a different user, we can able to do the simultaneous and continuous transmission in order for the effective utilization of the available limited frequency spectrum, and it is usually implemented in narrowband system as we have seen in the previous classes. So for example, if it is AMS is a FDMA bandwidth of 30 kilohertz and it is implemented. So these are the some of the features of frequency division multiple access. So you know that so only one phone circuit at a time cannot be used by the other user and wastage of resources. So once the particular frequency has been assigned to the particular user, though it is not used, it cannot be allocated or it cannot be used by the other users. So there will be a wastage of resources. After the assignment of voice, the base station and the mobile transmit simultaneously and continuously. The bandwidth of the FDMAs are relatively narrow, that's why it is called as narrowband system, and intersymbol interference is low and no equalization is required, and the complexity of FDMA mobile system is lower when compared to the TDMA. So since FDMA is a continuous transmission system, so only the fewer number of bits are needed to do the synchronization and framing as compared to the TDMA. So FDMA systems have higher cell system cost as compared to the TDMA. So it is somewhat costlier when compared to the TDMA. So FDMA mobile unit use duplexers since both the transmitter and receiver operate at the same time. Since once the particular frequency band is allocated for the particular mobile user, the transmission takes place continuously and simultaneously. So because of that process, the duplexer is essential for both transmitter and receiver operate at the same time. So this will increases the cost of the FDMAs. Hence, FDMA is most costly when compared to the TDMA system. So FDMA requires tight RF filtering to minimize adjacent channel interferences. So this is the FDMA number of channels that can be simultaneously supported by FDMA. So it is represented by capital N, that is equal to given by the formula BT minus 2 into B guard divided by BC. So BT is a total number of frequency spectrum. So B guard, it is a guard band. Usually the guard band is assigned between the two consecutive number of users in the wireless spectrum in order to avoid the interferences and the overlapping. So B guard is a guard band allocated at the edge of the allocated spectrum, and BC is the each and every channel bandwidth, and this is a pictorial representation for the frequency division multiplex axis. So this is the axis for frequency. So here the number of channels from 1 to n has been shared in the frequency scale. That's why it is called as frequency division multiple access. So here some of the comparison between the FDMA compared to TDMA. Only fewer bits are used for synchronization and framing. So it is costlier than the TDMA, and it uses a duplexer since the both transmitter and receiver simultaneous and continuous transmission. So duplexer, because of the use of the duplexer, the FDMA is costlier than the TDMA, and FDMA requires RF filtering to minimize the adjacent channel interferences. And here, what is the meaning for non-linear effects in the FDMA, right? So since many channel uses the same antenna, for maximizing the power efficiency, the near saturation power amplifiers are non-linear. This non-linearity causes signal spreading, and which will give signal spreading in the adjacent frequencies also. So here that is called as intermodulation frequencies. So intermodulation are undesired harmonics, we know that. So that interferences with the other channels in the FDMA system. It decreases the user's performance. Interferences outside the mobile radio band, which is called as adjacent channel interferences. So there is a need for RF filters which is used to reduce the intersymbol interferences, which makes the FDMA as a higher costlier one. So here, as we said earlier, the number of channels that can be accommodated in the available spectrum by using the FDMA system, it is represented by capital N, that is equal to the total bandwidth of the frequency spectrum minus the B guard divided by BC, right? Then this is an example for the FDMA, how to calculate the number of channels in the FDMA system. For example, if your total number of spectrum it is given as 12.5 megahertz, it is represented by 12.5 10 power into 10 power minus 10 power 6. And here this is the guard band, that is 10 kilohertz, which is represented by 10 E3 here, and divided by the each channel bandwidth, that is equal to 30 kilohertz, right? So when you calculate this one, the number of channels that can be accommodated by using the FDMA system is 416 channels. So that's all about the FDMA. In the next class we will see about the TDMA. Thank you.